Hello everybody and welcome. In the past few weeks we have worked a lot with squares and square roots. You've spent a lot of time learning how to simplify expressions including square roots or to work with square root formulas as well as with quadratic formulas. And one reason for this is that square roots will enhance our understanding of numbers in general. But another is that being comfortable with squares and square roots will help us solve a new type of equations called quadratic equations. And this will be a major topic in the next few years, and today will be your first introduction to it. So yes, you are lucky, and this is a very special day in your math education. So let's quickly remind you first of the type of equation that you already do know how to solve, because most of what we will learn will be very similar to this. What you already do know is how to solve a linear equation, where both sides of the equation are the formula of a line. So a simple example is 8x minus 12 is 20, where 8x minus 12 is the formula of a line, this line with gradient 8 and y-intercept minus 12, and y is 20 is also the formula of a line with gradient 0 and y-intercept 20, so just a horizontal line. So these are both lines, and basically when you solve this equation, what you're asking is for which x do these two lines have the same y value? And that is why such an equation is called linear. And we solve linear equations with the balance method. We only want to have x on the left-hand side and a number on the other. So that means in this case we want to get rid of the minus 12, and we can do that by adding 12. And we are allowed to add 12 on the left-hand side if we also add 12 on the right-hand side. As long as we do the same thing on both sides, we will be fine. So we add 12 here, we also add 12 here, and then we get 8x equals 32. Now we want to go from 8x to just x, so we divide by 8. We need to do the same thing on both sides, so we end up with x equals 4. And that means that these two lines intersect each other when x equals 4. It also just means that 4 is a number that completes this calculation. 8 times 4 minus 12 is indeed 20. Now a quadratic equation is called quadratic because at some point we square the unknown or the variable. But the question is the same. What number fits this calculation? So what can we fill in here so that this number squared is 25, for instance? Well, you will immediately think of x is 5, because 5 squared is 25. And indeed, x is 5 is a solution to this equation. But there's another solution. Negative 5 times itself also equals 25, because a negative times a negative is a positive. So negative 5 is also a solution. And we always want to find all of the solutions, or usually we want to find all of the solutions. So we have to give both of these answers. The solutions to this equation are x equals 5 or x equals negative 5. And the possibility of there being two solutions is new, so you have to take care not to forget it. So let's practice a bit. Let's take a look at these equations and try to find all the solutions. Maybe take a minute for that, or pause the video for a minute and see if you can find all the solutions by yourself. And then let's check your answers. So if x squared equals 49, then we want to find the square root of 49, which is 7. So x is 7 is a solution, but x is negative 7 will also be a solution to this equation. Negative 7 squared is 49. Some number squared is 5. Well, I can't find a whole number or a fraction, so I can just say that the answer to this, the solution to this equation, is going to be some number that is the square root of the square root of 5, because the square root of 5 squared will give us 5 again, or negative that number. Negative square root 5 times itself gives negative times a negative is a positive, and square root of 5 squared is indeed 5. So this is also just a perfectly fine solution to this equation. X squared is 0. What number times itself is 0? There's only one solution here, and that is x equals 0. X squared is negative 4. That means we are looking for a number that multiplied by itself gives us -4. So a number that multiplied by itself is a negative. Well, that's not going to be any number that we know. A positive times a positive is positive, and a negative times itself is also positive. So we know of no numbers that multiplied by themselves give a negative number. So in this case, we say that this equation has no solution. So that's also possible. So sometimes we have one solution, sometimes we have two, and sometimes we have no solution at all. Now, in any more complicated equation, for now, our strategy will be to try to get only x squared on one side of the equation and only a number on the other side, just like we did with linear equations for x and a number. This is not always going to be possible, and later we will spend basically a whole chapter on more difficult cases. But for now, let's not worry about that. Let's just look at an example again and use this strategy to solve the equation. 8x squared minus 12 is 20. So again, we're going to try to get just x squared on the left-hand side. That means we want to get rid of the minus 12 again. So we are going to add 12 on both sides. Now we have 8x squared equals 32. We want to go from 8x squared to just x squared. So we divide by 8 on both sides. And then we get x squared is 4. So we end up with x squared is 4. Now we have one more step to perform. If x squared is 4, then what can x be? Well, it can be 2, because 2 squared is 4, or it can be -2, because -2 times itself is also 4. And those are our solutions. And the rest of this video will basically just be more examples, including some examples of equations that don't get us a nice whole number or a fraction as a solution. But if you feel you've seen enough, you can just start practicing. And if you want to see some more examples, then keep watching. So in all of these examples for now, our strategy will be to work towards this form, x squared on the left-hand side and some number on the other side. And then our final step will be to say, oh, then x is the square root of that number, if that is possible, or it is minus the square root of that number. So let's look at a few examples there. Minus x squared or negative x squared plus 11 equals 2. We want just x squared on the left-hand side, so we get rid of this 11. So we subtract 11 on both sides. This becomes 2 minus 11 is -9. This remains the same, so we get negative x squared is -9. Now we want to get rid of this negative sign here. So we divide by -1 on both sides. And then we get x squared is 9. So there will be two numbers that fit. 3 squared is 9 and -3 squared is 9. So our solutions are x is 3 or x is -3. Another example, 5x squared plus 12 is 7. We want to get rid of the 12 first. So we subtract 12. Then we get 7 minus 12 is -5. So our new equation becomes 5x squared is -5. We want to get rid of the 5. So divide by 5. Then we get x squared is -1. So it says x squared is a negative number. Now our solutions will be the root of that number or minus the root of the number, but we cannot take the square root of a negative number. So this is where we stop and where we just say, nope, no solutions. There is no number that we can fit here. That's it. Okay, so like I said, sometimes your solutions will not be a nice number like 3 or -3, but just a square root of something. So that's something that we have to get used to as well. For example, here, x squared plus 5 is 10. Simple first step, get rid of the 5 by subtracting 5. Then you get x squared is 5. And we can't really, we can evaluate this. We can say x is the square root of 5, or of course it is going to be negative the square root of 5, but we can't simplify this any further. We can't give a nice number for the square root of 5. We just have to leave it at this answer in this case. So that's also possible. And in this case, usually you don't ask your calculator to round this number. You just say my exact solution is x is square root 5 or negative square root 5. of course, it may be the case that you get a result that you still have to simplify. So in our final example, we'll see an example of that. Negative 5x squared plus 20 equals negative 80. So first, let's get rid of the 20 by subtracting 20. So we subtract 20 on both sides. So we get negative 5x squared is minus 100. Now we want to get rid of the negative 5. So we divide by negative 5. So this becomes x squared. And this becomes negative 100 divided by negative 5. 100 divided by 5 is 20. Negative divided by a negative is positive. So we get x squared equals 20. And then, of course, that means that x is the square root of 20, or x is negative the square root of 20. But in this case, we can simplify this answer, because if you remember, square root of 20, we can split that. We can divide 20 by a square number, right? We can divide it by 4. So that means we can rewrite it as the square root of 4 times 5. And we can basically pull that square root apart and say, okay, so that's the same as the square root of 4 times the square root of 5. And then the square root of 4 I can still calculate. And we think this is a nicer result than this, because we want as small as possible a number underneath the square root sign. So our answers will be square root of 20 becomes 2 square root 5, or x is negative square root 20, so x is negative 2 times the square root of 5.